Let's go. You know what's up. Coding, coding, coding. So this is the reversed code. Len R. Mm, mm. Probability is 1. Previous click is 0. Position before the first click, treat as 0. For J in range, previous click plus 1 exactly to click 0. Okay. Okay, it will put it in the loop. Why is it then 0? Probability is 1 minus, you should not exit and you should not select because arrays are 0 base while positions are wise. So arrays are 0 exactly. I love this. Alright, then not exiting at U1 and clicking at U1. U1 is click 0 and the probability is 1 minus Q1. You are not exiting and you are now handle intermediate clicks for R in range, len of clicks -1, current click R, click R plus 1, survive and skip from current click up to the next click -1. For J in range, current click +1 to next click, you are 1 minus Q, you are not clicking, you are not exiting, then not exiting and click at the same. Probability equals probability times 1 minus Q times U, next click, you click. After the last click, no more clicks, no more click, last click is click -1, probability equals probability no click, last click +1, RQ. Where did you, okay, now we are computing probability of no click, last click +1, RQ. House full of fans and so on. All right. This is beautiful, honestly. Oh God, thanks. Probability of no click, start position, RQ. Probability that there are, I feel now we can focus more on the econ side, the things that I really care about, and put more of my time there instead of focusing on coding. Probability of no click, start position, RQ. Probability that there are no further clicks from position start pose onward. This sums over all possible exit positions or none with no clicks in between. N equals len of R. Positions in code are 1 base, so we adjust carefully. We sum over J from start position to end to handle the event that user exits at J or never exits. Perfecto. Total probability equals 0. Okay, because it is a summation. Exit position J in the start to position n -1. Surviving 1 minus 1 from M in this one, and then exiting at J. For J in the range, start pose to N. Survive position is probability is 0. For M in range, start position to J. Survive probability equals survive probability 1 minus, you survive 1 more. Exit at J, total survive probability times QJ -1. Alright, very beautiful. Plus the probability that the user never exists from the start position to N. Well, where is that probability? Total probability. But Qn is 1, so don't worry. Skip all and not exit at any position. For M in range, start position and N +1. If M is less than or equal N, survive all equals survive all times, yeah, you don't click, you go all to the end. Else is 1, else out of range, bring actually go in multiply to the end. There is nothing left to skip. What was that? There is nothing left to compare. We'll do it carefully. Survival for M. Start with n plus 1. And sounds good. Return total log likelihood mixture. Click list. Okay. RA, RB, and Q. What was Q by the way? Oh, quitting probability. Theta. And theta, we want to compute the total log likelihood from mixture model. Click list of each user's clicks. Each monitor is a list of click position RA vectors for A and B. Q exit probability length n theta. LL. What is LL? Is 0 for U in checklist click list. PA cascade probability U RA Q PB URB. What is the return of the cascade probability? Probability of U given R. Alright. Probability of U and RA and Q. Alright. Sounds good. And mix A is theta times PA. Mix B is 1 minus theta. Denominator, which is this. This if denim, you can hardly fit the denim. All right, your offer is waiting. Why do I look at my phone? And denim denominator, denom is less than 10 to the minus 14. It's very small. Gamma A dot append 0.5, else gamma A dot append mix A over denominator. Alright, so we are updating gamma, return gamma A. Now we want to go over the gradient. Honestly, I don't see the need for expectation maximization. We just need to have a gradient set to 0. That's what we need. Log likelihood is LL. All right. And where was this log likelihood? Okay. But we had some gamma. Where was the gamma? Type A, LL is 0. You can click. If makes it. Okay, LL. Alright, avoid log 0. If mix probability of B is less than 10 me, mix B. Mix prob is this. LL will also minus 10 to the minus to the 10. Big negative. Else NP dot log mix pair. Okay, so minus infinity. All right, return LL. Define E step. Where is gamma, by the way? I missed it. Oh, it is in E step. Compute gamma I for each user I probability type. We don't need to compute gamma i's for now, but return an array of length. So it says, in a sense, all right, we are not only categorizing items, the code is giving us odds of a user belonging to each category as well, which is good. It's nice statistics to have. E step compute gamma for each user I probability of time and click gamma A for U in click list PA cascade of this PB mix A mix B denom. If denominator is less than this, tell owner flow under gradient gamma A happens. We will say half and half. Otherwise, we say mix of A over denom. Makes sense. Now we want to go over gradient, right? Gradient descent, yeah. gradient R with respect to R. Maybe we can use that E step for estimating theta later. Gradient R, click list, RQ, gamma, vec. Compute the gradient of sum I, gamma I. Sum over I, gamma I, okay, the likelihood. With respect to Rj, oh, okay, just half of it, half of the summation. Here, gamma vec is either gamma A for type A or gamma, an array of length L on R. For simplicity, this code will do a numerical gradient approach using finite differences for production. You do an analytic derivative, but that's more complex to implement. And I don't want complexity. Fuck complexity. Epsilon is 10 to the minus 5. Oh. And G, what is G? NP0 is like R. Base objective is 0. So we are saying they are not relevant. First compute objective, sum I, gamma I, lie. At the current R, we'll store it. Then do a small perturbation of Rj, the approximate derivative. Yeah, we did. G and G are base object 0 if for I for each user and for their clicks in enumerate click list if gamma vector of I is less than 10 to the minus 4, so it is type B. Continue. What is you go for the next, but if it is greater than that, then you have P equals cascade probability of URQ. If P is less than this, which is the gamma, base objective is plus gamma vector I 10 to the minus 10. Is it the gamma vector? What is gamma vector? Is it the else? Is it the log? Yeah, it is log. For J in range, old value of Rj, forward step, Rj is minimum of 1 and old value plus epsilon. Why is this forward objective? I have to check this part of the code. For I gamma with I equal 10 to the minus 14, continue pre-cascade forward less than forward objective gamma G M step. Alright, I didn't get this part of the code. Let's understand it. This function approximates the gradient of the expected complete data log likelihood QR. This with respect to each component Rj of the relevance vector R using finite differences. Numerical derivative, it is used during M step of EM algorithm to optimize the relevance vector. Input click list, a list where each element is a set of click position UI for user R a numpy array of lengths and Q exit probability gamma vec array of the same length as the click list for each user, where gamma is the posterior probability that user I probability of belong to the type associated with this relevance. For example, this. Okay, all right, makes sense. How it works? Initialize variable is the small perturbation used for finite difference approximation. All right, I didn't know that. What the fuck is finite difference approximation? Now we learn it. I love ChatGPT. G will hold the gradient vector one partial derivative for each rj. G will hold the gradient vector one partial derivative for each rj. Okay, exactly. ROMs and dvd rj. Compute the baseline value for of the objective function. What is the baseline? P cascade view RQ if P is less than 10 to the minus 14 base objective. Right, and okay, I didn't get this part actually. This can be the current objective value. Base objective is gamma I. Yeah. Ah, fuck yeah. Okay. It's for each user. It is adding up. All right. We skip users where gamma is too small to wasting computation. If gamma is small, we are skipping, but if the p is small, we are continuing. We are considering it. Why? If a user has a clear intention that I am type B. Oh, okay. The summation is 0, but it shows up in the other summand, so we are fine. You skip the users with too small to avoid wasting computation or introducing noise. Very small, we cap the log at 10, avoid taking log 0. Alright, makes sense. J, compute the numerical gradient. Oh, I like this part. How do we do the gradient? Makes sense. Okay, find a difference on R and see how it changes. Oh shit, that's crazy. So we change R, yeah, because we need the gradient. I'm learning something new here. Yeah. Finally, this gradient descent is showing up in my life. We met each other finally. All right, for J in range length R, length. The old value is Rj. Forward step Rj is minimum of 1. Why is it min? Oh yeah, it is always, it cannot be more than 1, so we will max it up. Okay, old value plus epsilon. Alright, we slightly perturb Rj upward by epsilon to approximate the gradient numerically. Fantastico. Forward objective equals 0. What does that mean? Forward. Okay, I need to, yeah. Forward objective is computing the baseline objective for the new perturbed R. Alright. 0 for I in U, numerate gamma back I, this, continue by I in U, same thing. Okay, you just didn't update R, did you? Alright, this R is the updated R. Do you have me or no? Yeah, you have me. So this R is the new updated R. This computes for R objective. So it's a vector with one position J, 0 elsewhere. We are directional derivative, and Gj is for option. The final approximation. I love it. Rj old value return G gradient vector, which is then used in MSR for. Is it implement numerical gradient method for the cat? I agree. The one term I didn't know was finite difference approximation. Well, we learned. Alright. So we got this part, and then MS step is the maximization. We want to set the derivative to 0. Click list RA, RB, Q, theta, gamma A, and LR equals 0.01. What is LR? M step gradient ascent on Q R A R B gamma A I gamma A so gamma B I gamma in we do one gradient ascent step for each of this. LR is the learning rate, returns updated RA and RB. Okay. Build gamma B vector 1 minus gamma gradient for RA, gradient R, click list RAQ gamma A, perfecto, gamma RA new is RA plus, yes, it is updated, learning rate times the gradient. Bound them, RA new is np.clip, not less than 0, and above this, gradient for RB. Dude, it seems this ChatGPT is invented for me. Gradient for RB. What is gradient for RB? Same thing. What are you doing? Alright, EM cascade. Click list and Q theta max iteration equals to 20. Really, 20 is enough? Full EM procedure. Click list of user click sets, which is a sorted list of position and number of items, Q exit probability array length and theta mixture proportion for type A. A max iteration, number of EM iterations, LR learning rate for gradient ascent. I don't like to hear gradient ascent. Returns RARB after final iteration. Ascent. Sending. Sent. Alright. Sent. Returns RARB after finding. Initialize RARB random or here. We'll do random in this. np.random.seed. Did. Okay, we just randomized. Random uniform 0 to Durudun for it in range max iteration. For it in range max iteration here. What is it? Oh, iteration. Alright. Iteration, yes step gamma A is yes step click list RARB Q theta RARB. We can make it max iteration 1 or 2, I don't know. RARB M step click list RARB Q theta gamma A learning rate. Optional compute log likelihood for monitoring log likelihood mixture clicks. Yeah, we wanted to increase print F iteration. Alright, return RARB. Example, usage test. If name equals main, suppose we have n5 items with some exit probabilities Q entry.array. Click list. Suppose we have a mixture from, right? You know, these managers with ChatGPT coming, managers, we don't need as many employees as we used to, right? So managers one employee can do much more work now given the AI. So those employees we don't need them anymore. But now if you are a manager and you are removing all of these employees, you will be the leaf node in this hierarchy graph, and you will become an employee, and soon they remove you too. So I think if you're a manager, don't remove your employees, just try to get to the upper node of the graph and somebody else removes them. I think that's safer. Was it related to this? No. But was it, I talked about it before? Yes. Gamma A is step, RA, M step, click RA optional, click list. Alright, now let's see. I can get the click list from that. Yeah, let's run this code first. So the likelihood is increasing. Final RA is 0. RB is bigger. I cannot read them very good. Second one is 6 to the minus is 0.6, 0.4, 0. So they are both big numbers. Wait a second, how is that possible? Okay, based on these clicks, we can say, all right, what is n? N is 5. We want to probably say 1, 2, 3 are in the same category, 4 and 5 are in the same category. So RP, yeah, see, the last two are closer numbers for B, while the first three are not necessarily close. Anyways, let's try it on our own data. Alright, so let's go look at the other code. Maybe it generates already. Let's not get dumb using ChatGPT. Let's get smarter. Ooh! 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 Wow! Alright, clicks. What is this? Dude, I talk so nice. It's amazing. Let's not get what? Let's not get dumb using ChatGPT. Let's get smarter. Woo! Somebody commented below. Alright. Commented below. Import numpy as np from iteration tools. Import chain and combination. Single type probability of exact subset of clicks. No clicks probability, 0 based start. I'm so proud. Oh, no clicks probability, 0 based start. What is this motherfucker? Oh, this is just bullshit best. I want to see this part is expected number of clicks. Alright, but I don't think. Where is the fucking. Oh, okay, clicks and positions clicked. Well, what is the positions clicked option? Number of sessions 100. Clicks and positions. Click equals simulated cascade session. Type 0 based. Num sessions are 1 or 2 QP random series. Simulate average of click example. What is so this is the clicks and this is the positions clicked. Okay, it starts from 0. That's the only thing that here we started from. Alright, so we need to +1 then. Alright, I can do it later. And it also generates a list, so I'm fine with it. Oh, okay, we have the clicks list here. So how can I alright, let's ask GPT. What is it? Just that. What is EM? Okay, yes. Okay, that's amazing. I really like ChatGPT. I like it. It's very nice. It is fucking amazing. It does everything. For me to do this like 2-layered for loop in one thing, it killed me, and it was not fun after research. traffic. That makes sense. What is this pipeline, by the way? Everybody said, oh, I just did the pipeline. Fucking, I did pipeline finally too. Simulate. Let's
In machine learning, a pipeline is a sequence of steps that automate the process of building a model from raw data to predictions. It's like a production line for ML workflows. Lightbulb. Why use a pipeline? Automation, avoid repeating steps manually. Reproducibility, ensures consistent processing. Clean code, everything is modular and easy to manage. Prevents data leakage, ensures transformations are only fit on training data. Brick. Typical components of a pipeline. Pre-processing. Missing value imputation. Feature scaling, example standardization. Encoding categorical variables, example 1 hot. Feature selection or engineering. Creating new features. Dropping irrelevant ones. Model training. Choose algorithm, example logistic regression, random forest. Fit the model to data. Evaluation. Cross-validation.
Alright, let's do this then. Alright, yeah, we can. Oh, no. Yo, what's up? What is this? Can I move folder? Not folder. I want to make a project. Let's ask ChatGPT. More modular, exactly, keeps me. Start with option 1 while developing, then switch to option 2. Once. Alright, sounds really good. No, let me do it myself. Why? Okay. How can I not? What? Research, CSS. Together. So first we click simulate. Control Control C. Then we come here together. Control V, and then we do the adjustment. And then we add one. Category identification. Yes. Dude, that's fucked up. I'm really happy. The amount of coding I know is really good. It's the perfect amount. So we can run it now. Oh, we have now two main functions. Alright, let's fix this part too. Fucking don't call me an engineer. I mean, when you text me, doctor, only PhD. If I put it. It really sucks, honestly, for some people who spend all of their lives learning this stuff. insert cell above, edit cell type. How do I change it? Insert. Oh. Cell mark down like this. Oh, why does it look like that? And then insert cell below. Wow, thanks, honestly. Am I lucky? Am I blessed? Whatever. What is it? This life is amazing. This life is fucking amazing, guys. I'm falling in love. Oh, where are you? Part 2, that's it, copy. Okay. Let's run it, maybe it works, who cares? There are 2 main sections. And what is N here? Alright, let's... N is... I should go to the main part, right? So N is like 6. Right? No, it's 5. Wow, I cannot count anymore as well. Alright, then R1, R2. Sounds good. Let's run it. And then did I do it? Sounds everything going well. This part is the part that this part I have to remove. Okay, theta is 0.6. How much is it in the first part? P. What is P? Oh, 0.6. Wow, it's so random. So random on randomness. Dude, I have to... Where is it? Theta is 0.6. It's like P. Oh, call it P. Ah, click list is not defined. All right. First, then I just went down category. Can you just send it the code? Oh, okay, so it's not. Alright, that's not the. Yeah, that's what I need. Okay. Ah, so you're done. Now I want a kernel. Oh my god. Oh, this likelihood is terrible. That is not good. This is not good at all. What is the, by the way, what is this? Can you show us click list? Oh. So for, oh, okay, we know it actually. It's doing terrible. At least it has no bugs. So what are the R's that we generated with? R is 0 0.8, 0 0.1, 0 0.1, 0 0.9. So item 1 and 4 are in the same group, while item 1 and 4 in the same group, 2, 3, and 5 are in the same group. So if I like 2, 3, 5, 2, 3, why is it 2, 3, 4 all the time? It should be so 1 and 4, 1 and 4. But there is no 5, that's crazy. Why do we generate more? Nine, 7, yeah, 2, 3, and 5. Alright, now I wanna say I built this part of the code. Second part has more problem. These are fine, these are fine. Okay, what is the max iteration? I want to keep the iteration loop. Not the iteration, but E step. I don't like the E step. Forget about the E step. Forget about, yeah. Oh, okay. Ah, you got the Q wrong. All right. You're using a different Q. Let's use the same Q. Where is the? This is the Q we want. So that's a mismatch effect. Let's do it again. It was 1 and 4, 2, 3, and 5. First of all, RA and RB are so close. We expect them to be different. However, this time it got better, I guess. What else do I want to say? I like the M step. Let's get rid of the E step and let's focus on the maximization section. Yeah, let's do this. What is this fucking? I'm not even assuming that. Oh, okay. Maybe max iteration needs to change. What if we make it 100? Terrible, it's still awful. Like even 100 times. Didn't add much. You can see the increments are. Oh, it got stuck. You know, you see these loops? 725, 1039. 725, 1039. 724, 1039. 729, 1039. 4, 1039. Alright, let's try something else. Let's give it a stronger, like it is. 0.1, 0. Yeah, that's a good one. And wait, do we have that? Nobody gets 5. There's also one. Where is it? Yeah, let's make the list longer. So it is 1 for 0.9, I want to say 9. It is 8. It is 1. It is 0.7. And it is 0.1. Alright. So how many items? 1, 2, 3, 4, 5, 6, 7, 8. I say it is 75, and I want to say, well, actually more than, and then this one, 75, and then I have this one, which is 0.1, 0.9 to 5, I don't know, fuck that, 0.89, 0.1, 0.8, what else? And this should be 0.1, this should be 0.1, then it should be 0.8, I don't know, 77, and this should be 0.7. Alright, and then this should be 0.1, 0.1, 0.1, 0.2, 0.2, 0.2, how many? What is the length of 3, 9? So it is 3, 2 more. 0.3, 0.3, right? 3. Alright. P also, I wanted to, okay, sounds good. So items 1, 4, 6, 1, 4, 6, and 7 are in the same category. 1, 4, 6, 7. And that's it. And did I adjust accordingly? Q, I don't wanna. Theta is P, n equals 9, I guess. Oh. So what were the numbers? I forgot. It is 1, 4, 6, 7. 1, 4, 6, 7, one group. 1, 4, 6, 7. The other group will be 2, 3, 5, 8 and 9. 2, 3, 5, 8 and 9. Wow, maximum likelihood got worse. Why are you making it worse? So final, yeah, that's the fucked up thing with the, why is it decreasing? Look. I think it is the second part of the. So we expect 1, 4, 6, 7. 1, 4, 6. 1, 4, 6, 7. I like that. 1, 4. 2, 3, 5, 9. No, we don't want that. 1, 4, 6, 7. I like that. I want 2, 3, 5, 8, 9. 2, 3, 5, 9. 2, 3, 5, 8. 2, 3, 5, 7, 8, 9. This is amazing data. Alright, now tell me, why is this data set like this? Yeah, that's terrible. Yeah, we are seeing the cycles going wrong on there. Oh, okay, log of 0 is too much. Yeah, it is obviously that, because E step is feeling incorrect. I think that's one step we want to stop. We don't need E step. One, 4, 6, 7. Here's 1, 5, 6. Regularization. Yeah, I want to freeze E step. That's the best way to go. Yeah, I like that. Fucking, this is amazing. Let's try to freeze. let's, if this is, yeah, let's motherfucker. Where is the EM cascade? That's the biggest problem with Python. We don't have multi-line command. Or should we have? We don't have, I don't think. Oh, it's still 0. No, it's not the default value. Ah, that's much better. Ah, it again gets into the loop. Right, but let's look at the values. This time, this is up to, we get 9 or no? We get 9, alright. So it suggests RB is this, like, below, and RA is all these small numbers. Yeah. What are we doing different on RA then? mstep. So it's everything. It is saying that the code is matching and it is more. Actually, okay, two and 4 in one group actually. Fuck up. Yes, the. So let's. Oh. Don't give random. Where's the gamma? Ah, increases. What the fuck? So it was one. Oh, actually pretty good. Wait a second. What was it? 1, 4, 6, 7. 1, 5, 6. That's terrible. Likelihood increases and just let's do 10 to the minus. Like fucking 6. Oh, it got worse. Alright, so alright, let's just stop it here. Where is it? So let's. How is that possible that RA and RB are totally different? Oh, it's getting better. So lower the 1, 4, 6, 7. Yes, 1, 4, 6, 7. So it depends heavily on where you start. 1 and learning rate. Learning rate matters. 1, 4, 6, 7. Then it is 2, 3. Then we have 5. Then we have those are low numbers, but 8 and 9. That's better. What if I make it like one more? And then how is the change? Like improvement over iteration is terrible. That's one more. Ah, oh, I see, I see. Okay, makes sense. So I rather. So okay, 340. What is a normal? Yeah, we can improve the max iteration part for sure. Learning rate 0. Adaptive tip. I see. That's good one. We can do it later. So you can see that it is still 0. Minus 300. Is it improving? No, it's actually just oscillating. So we have this oscillating behavior. There is no point in. Alright guys, I will stop it here. I think we got something. We got those numbers, but we need to improve this.